So this time we will talk about lesson 2.5, cubic functions and transformation and polynomial functions of higher degree. So in this case, we better know the parent function of each case. Okay, so the last time we talked about that the quadratic function case, x squared, that is the parent function. And based on this, we can find its transformation, such as given gx equal to x squared maybe plus b, then fx equal to x squared moving up b units, right? And then given hx equal to x squared minus b, the same thing, the fx equal to x squared moving down b units. So similarly, we also confirm that given gx equal to x minus b squared, then fx equal to x squared moving to the right, b unit to the right, and then given hx equal to x plus b squared, then fx equal to x squared moving left to b unit. So based on this fact and this property, if we have any given function is a x equal to x minus b squared plus b, then we can apply this up and down, and then right and left property here. So this case, this is C. Then we can say right b unit up C value like that. So let's look at one example. If given gx equal to maybe x plus 3 squared plus 5, then basically this case we can apply this property and this property together, so become left 3 units up 5 units. So we drew the graph now using its transformation. So basically this is the y equal to x squared graph. Then now we can draw this one simply moving left 3 units and then up 5 units. And from here we have exactly same y equal to x squared curve here. Then this is going to be gx equal to x plus 3 squared plus 5. Now, what about the cubic function? So cubic function is formed as x cubed. So let's find some few points and then draw this graph here. So maybe 0, 1, 2, negative 1, negative 2. You plug each x value into fx, then you will get those outcomes are 8, 1, 0, negative 1, negative 8. So we plot those points on the plane graph here. So 1, 2, 3, 4, 5, 6, 7, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8. So points are 0 and 0, 1 and 1, negative and negative 1, negative 2 and negative 8, and 2 and 8 here. So if you connect them, then it looks like this. So that is the fx equal to x cubed function. So now what if I'm asking gx equal to x cubed plus 2 then? So based on the quadratic function policy, we may conjecture in moving up 2 units up here. And this is correct. So since we know this is cubic function graph, now moving these 2 units up and make the graph like this, then that is going to be gx equal to x cubed plus 2. And similarly, if given hx equal to x minus 1 cube, then before, when we talk about quadratic function, inside value always moving right over left, right? So this one we can apply exactly same way. So inside one, so it moving 1 unit to the right. Therefore, the original function is this one. Now the hx function moving 1 unit to right here and becomes like this. So there will be hx equal to x minus 1 cube. So then now you can guess the graph of this function. So ax equal to x plus 2 cube minus 2. Think about what we have learned from the quadratic function. Then we can guess the graph of this one. So inside one moving left 2 units and outside one down 2 units here. So on the plane graph, original function is this one. Now this will be moving 2 to the left and down left 2. So it becomes like this. So that will be our ax graph. Okay. Then what about the given gx equal to negative x cubed? Before, when we talk about gx equal to negative x squared, we flip based on x-axis. So the original graph was this, and now it reflects x-axis, so you would have become downside here. Now, so we can apply same property. So the basic cubic curve is this, right? Now, because negative in front here, so it reflects by x-axis. So this part moving up and this part moving down. So the red one indicate gx equal to negative x cubed graph. So let's talk about a little bit more detail of the function transformation. What if I'm giving you any equation, maybe hx equal to 3 minus x cubed? Then you can rethink this one, hx equal to negative x cubed minus 3 or plus 3. So in this case, the center is x equal negative x cubed, y equal to x cubed. That's the center. So you know that negative x cubed graph is this one, right? And now because of this, we are moving up 3 values. So 1, 2, 3. So this become like this. Okay, let's go into a little more deeper concept here. So given gx equal to, now negative x minus 4 cubic plus 4. Can you conjecture how in moving from a negative x cube graph? Yes. So y equal to negative x cube will transform to 4 to the right of 4 again. So graph is originally this is the negative x graph, and then now in moving right 4 and then up 4, so become like this. Okay, the last part of this video we are going to talk about difference between fx equal to x cube and gx equal to 2x cube and hx equal to 1 over 2x cube here. To understand better, I'm gonna make a table and then compare those values. So x value 0, 1, 2, negative 1, negative 2, and then this is x cube, 2x cube, 1 over 2x cube here. We know original function value, which is 8, 1, 0, negative 1, negative 8. Now this means we're doubling them here. So become 16, 2, 0, negative 2, negative 16. But now this case, we are half of them. So become 4, 1 over 2, 0, negative 1 over 2, and negative 4. Okay? So let's using GeoGebra and look at those graphs, and then we can talk about a little more. So this given green line is fx equal to x the cubic graph here. Now I'm gonna turn on 2x cube function here. Then what's gonna happen? So red one is 2x cubic function, and then let's zoom in. So see a little more detail how it differs here. Okay, do you see what's difference here? So as you see, red one is kind of inside of green line here. Okay, at the same time, if I turn on the hx equal to 1 over 2x cube, then the blue one is basically compared to green one outside of the green line here, right? So based on this, we can say that if this value is bigger than 1, then graph is steeper and steeper. So let me make another one, maybe ax equal to 3x to the cubic. Then what happened? It's even steeper here. So let me compare 2x cube and 3x cube. So 2x cube, so this is x squared, this is the 2x squared, this is 3x squared. Let me make another one. Then the purple one is more inside here. So this coefficient value is getting bigger and bigger. Then this graph line getting toward that y-axis here, right? Then which means it is steeper and steeper. So let me read here. So look at this. So it's getting the coefficient is getting bigger than graph approach to y-axis more and more, which means steeper and steeper. Okay, so let me make another one. Y equal to maybe 100x to the cubic power. Then what happened? So as you see, this one is way here compared to green line. So I'm going to turn it off all other functions so you can see better. This is 100x cubic power. This is just x cubic power. So as you see, this one is more close to y-axis. And then on the other hand, half x here